moving on now to page 2 of the 7.4 leftover notes. I apologize for getting the labeling wrong there. But these are the leftovers from 7.4. We covered the 2 term special formulas earlier in the lessons. And we're coming back to this now that we know how to factor 3 terms. We're looking at yet just another way to speed things up for ourselves if we can recognize that it's a perfect square trinomial. What if you run into something like this, where you've got it's number 54 and it's x squared minus 7x plus 49. And we, of course, go through our usual routine. The first thing we do is we check, is there something, a GCF, greatest common factor, something that all 3 terms have in common? Answer is no. Very boring list of questions here, but it helps us be ready to factor. The second thing we ask to be boringly good at factoring is how many terms are we looking at? Now again, we're in the section on factoring special or perfect square trinomials, so it shouldn't be any shocker that we're looking at 3 terms here. And we have a choice. We can use trial and error, which is what the book really talks about. We haven't highlighted that much here in the notes. I'm happy to do that in class. Just make sure you ask me and I'll show you examples of how you can do trial and error. There's also a box method, which is very similar to what we've been presenting in the lessons, just does it more in a visual box version instead of the linear that we've been doing it in. And that is to convert 3 back to 4 terms so that you can factor by grouping. The other option that we're now looking at today is check to see if it's a perfect square trinomial, because if it is, there's a nice little instant sort of factoring formula that you can put it into. How do you check? Well, this is what we did on page 1. Let's review real quick. We look at our a value, our b value, and our c value. In this case, our a value is 1. It's that number in front of the x squared. Our c value, of course, is the constant. The b value is in front of the x term. It's the middle term. And we'll just note the sign, because we'll use the sign later. Right now, we're just dealing with the number 7 in this case. And then you ask yourself, is 1 a perfect square? And indeed, 1 is a perfect square, and square root of 1 is just 1. And 49 is also a perfect square. So we've met 2 of the requirements for it to be a perfect square trinomial. If it is, then we get to use our special formula for factoring it. 49 is a perfect square as well. Square root of 49 is 7. And then the third check, it has to pass, oh, sorry, let me make sure that didn't get too off the page. Oh, it did. Sorry about that. I ran into my own camera there. Okay, I think we're back on track now. Thank you for your patience. Okay. The third thing we check for is, can we then take, is b equal to twice the square root of a times the square root of c? These 2 square roots doubled. So in this case, we take 1 times 7 and we double it. Here's the 7, here's the 1, and we double it, and that equals 14. But 14 does not equal our b equals 7 in this case. Okay? So this one is actually not a perfect square trinomial. And the cool thing is if you have checked for this and you actually do have, it passes the first test of perfect square and perfect square, but it doesn't pass the middle test, chances are you might be looking at a prime. But here's how you confirm that for sure, as you go back to your 3 to 4 terms, factor by grouping, or your trial and error. So you take your a times your c value. So the question is it prime? Well, take your a times c, which is equal to 1 times 49, or just 49. And we do our strategic split. Make sure, yeah, I'm still in view of the camera. 1 times 49, 7 times 7, those are the only possibilities here. And you look to see if any of those will add. The plus here reminds us to add. And we're trying to add them together to get 7. And because it's going to be a negative 7, we're actually going to be adding 2 negatives together. Because when you add these, you have to still multiply to get a positive 49. So these would both be negative. to try to get a negative add here, but there's nothing we could combine. You get negative 14 and negative 50. You don't even come close to the negative 7. So there's no pair that adds to equal our b value. So this one is indeed prime. No GCF. No way to factor the 3 terms, so this one is prime. And I'm just going to go ahead with this video clip and we'll finish out the page here. On page 441, you'll find a helpful reminder for how to factor perfect square trinomials. So it looks, here's that doubling of the square root a and b, and here's the doubling of the square root a and b. And then notice they highlight the same sign. If it's plus in front of the b, it's plus in the factors. Minus, it's minus. And again, they use the shorthand version by using the exponent, but it really is equal to a plus b times a plus b. And this is really equal to a minus b times a minus b. Either way is a fine way to write your answer. I'm totally acceptable. Okay, either in the shorthand version using exponents or written out with both factors. Okay, and there are some review and preview exercises to do at the end of the assignment, and then you're through the 7.4 leftovers.